Do you need high performance RF in your next design? Well, if you're working on a long list of projects, including datacom, a military or aerospace design, or maybe something in the instrumentation realm, you are going to need to think about improved stability with flexure over time when it comes to the cable technology included in your design. You'll also want to consider a solution that is optimized for high frequencies and a construction that is robust and durable. But where can you find a cable solution like that? Right here, my friends. Right here. Hi, I'm Amelia Dalton, host of Chalk Talk. In this episode of Chalk Talk, Matthew Burns from Samtec and I explore the benefits of Samtec's Nitrowave cable technology. We also investigate the innovative interlayer composition of Nitrowave cables, the variety of RF design and development services that Samtec offers, and how you can get started using Nitrowave cable technology for your next design. And before we get started, don't forget to click that link. There you can find even more information about this topic from Samtec. Hi, Matt. Thank you so much for joining me.
Amelia, good to be with you again.
Excellent. Good to have you with me. All right. So, we're talking about high performance RF microwave cable assemblies today. But, Matt, at the heart of these solutions is high speed connectivity. So, what do you think is pushing the need for higher and higher connectivity these days?
Amelia, the answer for that is simple: ChatGPT. I say that jokingly, but think about how disruptive our daily lives have become as a result of all the innovation that's going on with AI. Everyone I talk to, my friends, my family, my coworkers, my daughter, her schoolmates, her workmates, my son, he's in his 20s, college aged. Everyone's using AI for all facets of their life. And the demand for AI is driving AI data center build out, roll out, scale up, scale out, something along the lines. The top four hyperscalers just in 2025 alone are spending $300 billion building data centers to support all the various flavors of AI that's redefining our daily lives. Now, that's an oversimplification, but it's not far from the truth. When we look at the ecosystem that we're a part of, AI is obviously very disruptive. It's in the we're in the zeitgeist in terms of everyone's awareness of it. It's just a massive investment that's going on and building out that functionality. But other technology trends are driving the need for high data throughput, 5G, 6G rollout, high performance computing, Auto 2.0 with electrification, autonomous vehicles. I was in San Francisco recently for the first time in years and was surprised seeing Waymo self-driven taxis everywhere. It's actually a cool experience if you've never done that before. But all this technology needs data throughput. And while some of that is wireless, obviously at the edge, you need to have backbone or data center connectivity to support that. And when you have silicon running at 112 gigabit per second lane, 224 gigabit per second per lane, and the next generation 448, there's the need to test that silicon. So we see all these demands for increasing data throughput, and Samtec is able to support that because of our innovative silicon to silicon solutions, a part of which we're going to talk about is our high performance RF microwave cable assemblies.
Fantastic. Now, do you have any specific case studies you can share in this case?
Yeah, so we kind of talked broad picture in terms of some of the trends that are driving the demand for data throughput, AI, 5G, 6G connectivity, et cetera, et cetera. If you start to dig a little bit deeper and start to look at the granularity of that is, if I have a 5G, 6G chipset, how do I test that? If I have a bleeding edge 224 SerDes or transceiver, how do I test that? If I'm working on a next generation AI acceleration platform, GPU, TPU, FPGA, NPU, XPU, whatever, there's high speed SerDes technology on that. So how do you test that? And if you look at these two pictures, they kind of cover those use cases. So on the left-hand side, you'll see some of Samtec's high performance RF microwave cable assemblies used on an ISI platform to verify performance of a 224 gigabit per second PAM4 SerDes. Why is that of interest? Because even though transceiver technology is thought to be digital, it still has to operate with optimized signal integrity in the RF or frequency domain. So a 224 gigabit per second PAM4 SerDes solution has a Nyquist frequency of 56 gigahertz. So when you look at that signal in the frequency domain, you have to make sure that the insertion loss is optimized, there's no crosstalk, there's no return loss or minimal return loss, optimized return loss. And the only way to do that is to connect the SerDes technology, the ISI test platforms, up to VNA test equipment using high-performance RF microwave technology. That's what you see in the left-hand picture. On the right-hand side, totally different application, 5G, 6G infrastructure, phased radar array infrastructure. They use beamformer IC technology. There's lots of bands, but in this particular application, we're showing how a 24 to 40 gigahertz beamformer IC from a name RFIC vendor is hooked up to a network analyzer using Samtec high-performance RF microwave cables to cleanly take the signals from the reference platform to the network analyzer so that an RF engineer can analyze the performance, not only of the chipset, but also of the RF cables. Both of these use cases, Samtec has worked with partners at recent trade shows. So these are just indicative of some of the use cases where Samtec's high-performance RF microwave cable assemblies are used for testing current and next-generation digital ICs and current and next-generation RF ICs.
All right. So, Matt, talk to me about Samtec's solutions in this arena.
Sure, and that's the reason we're here today, Amelia. Samtec has been a RF interconnect provider for decades. But probably about 5 to 7 years ago, we realized that there was an opportunity to take the signal integrity expertise that you and I have talked about many times and kind of apply that to the RF ecosystem. We really focused on how can we differentiate ourselves versus a lot of our competitors. And, the high level thought process was let's build a portfolio of PCB level interconnects, cable RF interconnects, and differentiated RF cable that would set Samtec apart from our competitors and allow us to help support differentiation with a lot of the needs that we saw across millimeter wave microwave applications. So one of the latest innovations that we've been working on is what we call our Nitrowave cable technology. Obviously, there's a number of cable technology solutions available in the market space, but Samtec was focused on leveraging the expertise that we've created with our ultra-low skew twin-ax cable, which is growing exponentially in the digital domain, and trying to take some of those best practices from an engineering standpoint and apply it to the RF domain. So that was really the foundation of our Nitrowave cable technology. It's really the same team. We've expanded a little bit with some RF expertise. And the end result is just developing our Nitrowave cable technology. The key differentiators that Nitrowave brings are phase and amplitude stability, even when you have a flexing cable over time. In the lab setting, like we considered with some of the case studies, you may connect the cable on either end and then leave the cable still while you're testing it in a controlled environment. But when cables get in the real world environment, there's going to be movement, there's going to be shock and vibe, and the more the cable moves, the more that can potentially affect the performance of the RF signal channel. So we really focused on designing a cable technology that would have improved stability as the cable would move or flex over time. So some of the key features of our Nitrowave cable technology is a coaxial structure with an outer jacket colored in distinctive Samtec orange, consistent contact resistance between layers, lower density dielectric, which minimizes losses. We use state-of-the-art shielding techniques and interlayer. Again, that's leveraged from some of the work that we have gotten better at with our high-speed twin-X cable technology. There's silver plating enhancements to mitigate corrosion potential, electrical performance optimized for next-gen frequencies. What does that mean? Well, if you look at the loss profile on the right of this slide, we could have picked any frequency bands in terms of why we created this Nitrowave cable technology, but we really wanted to focus on carrier frequencies that were popular or had the most demand based on some of the trends that we see in the ecosystem. A good example of that, 224 gigabit per second SerDes has a Nyquist frequency of 56 gigahertz. Having a 71 gigahertz or 70 or 71 gigahertz cable, to give you some extra margin to look at the signal integrity and the RF integrity past Nyquist is ideal. So we've seen a lot of adoption with our LL71 solutions for high-speed SerDes. Similarly, we talked earlier about the 5G ecosystem, phased radar array, SATCOM, those type of applications. You're looking somewhere between 24 to 40 gigahertz of operation that's of interest to those applications. So our LL43 solutions make sense for those type of applications. Why is that necessary? Well, when you look at phase versus bending, there's some RF math that we're not going to go into in deep detail here, but we're trying to find the right balance of dielectric thickness, cable wrap thickness, and cable size to give us the most stability over flexure over time. Not only does it give good stability, we also have really good VSWR. A good example of that is we have a VSWR VisWR 1.4 to 1, 43.5 gigahertz for the LF43 series. And again, depending upon frequency range, we kind of alluded to this earlier, this Nova Ray cable technology has found homes in aerospace, defense, datacom, which is the SerDes technology we've talked about, computer semi, instrumentation, industrial, and more.
So, Matt, talk to me more about this Nitrowave cable technology.
Yeah, happy to do that, Amelia. And we alluded to this a little in the previous slide about the technology that's actually built into the Nitrowave cable that gives it its performance edge. And when you look at the illustration here on the left, it really shows the multi-layer approach that Samtec has taken to develop this cable to give you that optimized stability over flexure and over time. Just going from the outside in, we use a Samtec Orange FEP, that's a fluorinated ethylene propylene jacket that provides mechanical environmental robustness as well as resistance to abrasion. You'll see that we have a silver-plated copper braid, which enhances the mitigation of corrosion. We have what we call our DPL, or our dynamic performance layer. This is a thin layer of PTFE placed between the foil and the braided shields to help with flexibility and stability of the cable, while also helping to optimize the RF performance. We have a silver-plated copper helical foil, which helps with grounding as well as mitigating corrosion potential. From a dielectric standpoint, we use a low-density PTFE dielectric, which minimizes RF loss. And then finally, we alluded to this earlier, we use a silver-plated copper conductor. The silver plating not only helps optimize RF performance along the cable itself, but also helps to mitigate corrosion potential. Something else that we show is how the inner layer, the DPL that we call it, helps to improve stability of the system over flexure. So the addition of that inner layer provides stability, which provides more accurate and dependable performance. So, if you look at the phase change, quote unquote, good stability versus flexure, there's not much phase change. But if you look at a corresponding cable assembly without that inner layer, you'll see that there's less stability over flexure. So adding that DPL layer really helps us to show that material science innovation can help RF and SI performance over frequency range, over stability, over flexure as well. And that's really the heart of our Samtec Nitrowave cable technology. So as we go into the next slide here, Amelia, this helps us to see not only the diversity of frequencies that Samtec supports with our Nitrowave cable technology, but you also see how flexible it is in how the cables can be designed and manufactured. We have Nitrowave cable technology available from center frequencies from 18 gigahertz all the way out to 110. You can see the outer diameters of the cables. There's a minimum static bend radius, which is important when it comes to applications where cables are flexing. Forgot to mention the base impedance of our cables is 50 ohms. Max shielding effectiveness, 100 decibels. Temp range, when you're in the real world, having as wide a temp range as possible is always a good thing. So our Nitrowave cable technology supports applications anywhere from minus 65 C to 125 degrees C. That covers commercial temp, automotive, a lot of mil-aero applications as well. Obviously, the insertion loss is going to change based on the targeted max frequency. We have that data available. And what's of interest is that one cable center frequency is not tied to any one cable connector size. So we can support standard compression sizes, 1 millimeter up to 2.92 millimeter, plus SMP, SMPM, SMA, and type TNCA. It's really limited by the imagination of our RF engineers as they create RF cable assemblies they need for their specific application.
So, Matt, within the precision RF family, what kind of solutions and support does Samtec offer?
Amelia, it's always fun talking with you because you're always eagle-eyed. And the reason I bring that up is I appreciate your observation that the Nitrowave cable technology that we're featuring is a part of Samtec's overall precision RF family. We talked earlier about how Nitrowave can support frequency ranges from 32 gigahertz all the way up to 110 gigahertz. But when you look at the wider Samtec precision RF interconnect solution family, we can support technology from 18 gigahertz all the way up to 110 gigahertz. And where that comes into is three specific areas. Nitrowave cable technology is our leading technology within this space. But if you're just routing 2.4 gigahertz Bluetooth or Wi-Fi signals, standard RF cable makes sense. So Samtec not only has the Nitrowave cable technology, but we also have standard RF cable solutions as well for lower frequency ranges and more commercial applications that Nitrowave may not make the most sense for. We also have a wide selection of connectors, both on the PCB side and also on the cable side for RF. The team that we've developed has decades, if not centuries, of design and fabrication experience, not only on the cable side, but the board side, like I mentioned. And as you and I have talked about in the past, when it comes to technical support for our digital and analog interconnect solutions, we offer full system support for our precision RF applications, launch optimization, simulation testing, full system optimization. This vertical integration of cables, PCB, and cable connectors and tech support really differentiates Samtec from a lot of our competitors when it comes to RF interconnect.
So, Matt, for RF design in particular, walk me through what Samtec has to offer.
That's a great question, Amelia. We alluded to some of these capabilities or these details in the last slide, but I just want to take a minute and kind of do a deeper dive into the technical design, development, support capabilities that Samtec offers. So launch optimization and design services. We can have the best RF connector with the cleanest, most optimized simulation details. But if you don't terminate that RF connector correctly to the PCB, provide for an optimized launch of the RF signal, and then build the appropriate grounding scheme, whether that's with vias or with the way you put your ground layers on the PCB, you're not going to get optimized performance. So launch optimizations for every application almost have to be optimized for an end solution. And our team offers those support, working with our customers, OEMs, tier one, startups, mom and pops, whatever. Come to Samtec and say, look, I need a connector for a 40 gigahertz application. Help me launch it. We're happy to do that. That's part of our design services. We also look at the performance of a system holistically. So 3D modeling, most engineers are going to obviously identify, okay, we'll do that from an ECAD standpoint, but we actually look at the entire system holistically from a multi-physics standpoint. So, how does the channel structure affect magnetic fields, E-fields, thermal, optical, et cetera, et cetera. So we have some of the leading multi-physics simulation tools in the industry that allows us to optimize not only the connector design and launch optimization, but the entire channel. We also look at E-field simulations, to see how the RF channel radiates within the ecosystem, how external EMI can be induced on the system to affect its performance. Simulation, prototyping. After we've built the products, we actually physically test and measure, verify the performance of our interconnects in a lab setting and real-world applications as well, all with the intent of continuing to iterate to create optimized solutions, application-specific solutions that make our customers and designs work the way they want to. Full channel analysis, system support, optimizing, designing, modeling, simulating the system from point A to point B to make sure it works appropriately, and then application-specific design and development assistance as needed for our OEM customers to optimize not only the Nitrowave cable technology, but all of the precision RF interconnect solutions that Samtec offers.
So, Matt, can you recap your main points for me?
Love to, Amelia. One of the key takeaways is obviously our new high-performance RF microwave cable assemblies. We call it our Nitrowave cable technology. That's ideally suited for testing any number of high-performance applications. In our Chalk Talk today, we just talked about how Nitrowave cable technology can be used to optimize the testing of 56 gigahertz / 224 gigabit per second PAM4 SerDes technology as cutting edge, bleeding edge 448 PAM4 or PAM6 technology comes out. Nitrowave is also positioned to help with testing those capabilities as well. We've alluded to the fact that Samtec continues to invest in our team of RF technical experts. We're expanding our team of product management. We're expanding our team of our RF application engineers, our field applications engineers, our RF interconnect designers. We offer online design tools, world-class customer service, all of that available immediately for any of your listeners as they design next generation precision RF signal channels and interconnect solutions. We backed it up also with our technical documentation. So specific to Nitrowave, we have our cable stability data e-brochure, which shows the stability of each frequency version of Nitrowave over Fluxure. We have a Nitrowave RF orange cable e-brochure, which highlights the whole product family from a feature and benefit standpoint. And then we also have our latest and greatest updated Precision RF microwave millimeter waveguide interconnect solutions guide that focuses in on our entire RF family. Obviously, all of this technical documentation and our Nitrowave product family is available from our partner at Mouser. So for more information, please visit mouser.com/Samtec. And if you need immediate tech support, please email Samtec at rfgroup@samtec.com.
Fantastic. Well, Matt, I think that's all I have time for today. Thank you so much for joining me.
Thanks, Amelia. It's always a pleasure talking with you.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from Samtec. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EE Journal.